Hey everyone, welcome to SQL Land. Before we start flinging select statements like ninja stars, let me introduce our three VIP tables. The calendar table is basically the Chronicles of Narnia for Wall Street. It lists every single day from January 1st, 1900 all the way to December 31st, 2050. Weekends, holidays, Y2K, you name it. We stuffed in handy columns like day of week, month name, year number, even the day number of the month, so date filters are painless. SQL rule number 1. No trade can happen on a date that doesn't exist here. Think of calendar as the bouncer. If a date's not on the list, it's not getting into the party. Next up, our corporate phone book. Each row in the company information table is keyed by ticker symbol. We keep the boring but essential stuff: company name, phone number, address, city, state, zip code, country. Plus an industry column so we can ask big juicy questions like, what did tech stocks do last Tuesday compared to energy stocks? Bottom line, the table catalogs 100 companies, giving us the who and the where for every ticker symbol in our data set. Finally, the star of the show, stock data, tied to calendar by trade date, tied to company information by ticker symbol. For every business day, we grab the prices ST_open, ST_high, ST_low, ST_close, as well as the volume of shares traded. So if you want to know how many shares of GameStop traded the day memes broke the internet, this is your table. With these three amigos in place, we can spot price spikes on specific weekdays. We can compare industries across decades. We can catch data errors. For example, if ST_high is less than ST_low, we know something's fishy. And yes, even build your first predictive model after your dirty Diet Coke. So that's the lay of the land. Calendar keeps time, company information keeps identities, stock data keeps the receipts. Ready? Grab your keyboards. We're about to write our first queries and make this database sing. Let's do it. All right, let's pull our very first data set. Follow me, this is quick. The first question is list all columns and all rows from the company information table. The first thing we want to do is open a new query window. We also want to make sure that the drop-down box has your database name in it. Type the answer to the query, then to run it, click Execute. The results pop up below. Ticker symbol, company name, industry, phone number, address, city, state, zip code, and country. Notice also that there are 100 rows in the result set. Now let's talk about the SQL query itself. Select star is SQL speak for give me all the columns. The from clause says which table has the data and the columns that we need. We are going to include a semicolon at the end to terminate the statement. It won't matter much now or for the next several queries, but it will matter later on. Welcome back, data wranglers. The calendar's keeping time, company information knows everyone's name, and now it's time to rummage through everyone's wallets, portfolios with stock data. Query 2 is going to give us a quick peek at the data, the first 500 rows. We're doing this because we don't need to look at an entire table with possibly millions of rows just to make sure the columns look sane. A top 500 sampler is like scrolling the first page of Netflix. Fast, harmless, and you instantly spot anything bizarre, like a closing price lower than the low. Yikes! Let's go ahead and answer the question. We need to click New Query, and then we need to make sure that we're on our database. Let's go ahead, write out our query. Select star means that we are going to return all columns. Top 500 means that we're going to return the first 500 rows. We don't have an order by clause, so we have to assume the table is in some random order. From stock data is the table where all of our data is. So here we're selecting the first 500 rows and all columns from stock data. I click execute, and down here are the first 500 rows. You can see that all columns have been selected. If you look down here in the bottom right-hand corner, you will see that it says 500 rows. Voila! We just swiped right on the first 500 rows. If everything looks normal, we'll unleash the bigger dragons, joins, filters, and maybe even a window function or two. Stretch those fingers. Query number 3 is where we start slicing and dicing. Here is the question for query 3. List the ticker symbol, trade date, and volume columns from stock data. Let's go to SQL Server and type in our query. First of all, click New Query, type in the SQL, and click Execute. Remember, the Select clause says which columns are going to appear in our answer. The first ticker symbol is the who. The second trade date is the when. Third is volume, and that's how many shares of a given stock changed hands on that day. Remember, the from clause says which table is in play. Notice in the answer that it's those same 3 columns that are listed. In summary, we get what we expected, which is a tidy list of trades, 1 row per date symbol combination. We show exactly 3 columns, no surprises, no clutter. Let's do the question for query number 4. List all attributes for companies headquartered in California. In order to write the SQL for query number 4, ask yourself these questions. 1. What table has a column with California in it? 2. How do I return all columns? And 3. How do I specify the state being California? So let's click New Query in SQL, and I'm going to paste in the answer. Click Execute, and see the results here at the bottom. Here's the answer, and as I scroll across and find state and scroll down, you'll notice that every company is in the state of California. In summary, let's review how the query worked. The from clause is used to specify the table, which is company information. Select star means that we are going to return every attribute from the table listed in from, which is the company information table. The where clause acts as a filter, and we are looking for only those rows where the value of state equals CA, representing California. Let's do the question for query number 5. List the ticker symbol, trade date, and volume for trades whose volume was under 10 million shares, ordered by ticker symbol and date. Let's go to SQL Server, click New Query, we'll paste our answer, and then we will click Execute. Let's review the answer for query 5. Notice that we have ticker symbol, trade date, and volume in the select clause. Those columns exist in the stock data table, so that's what we have to put in the from clause. The where clause is where we have the filter, and that is volume being less than 10 million shares traded. We are asked to put our answer in an order, and it is first by ticker symbol and then by trade date. That means if it's the same ticker symbol, then we invoke the secondary sort, which is trade date. Let's read the question for query number 6. List the ticker symbol, opening price, and closing price for trades that opened below $120 and then closed above $120. Sort by open and close prices. Let's think about how we are going to solve this problem. The select clause is where we choose the three price-related columns. The from clause is where we will specify the table, which is stock data. The where clause is where we are going to make our filter. We will have two conditions tied together with an and. That means both conditions must be true. We are going to do an order, and the primary column is going to be the opening price. The secondary sort is going to be on the closing price. Students need to create a new query window in SQL Server Management Studio, type in the SQL in new query, and then execute it. Let's go ahead and execute the query. Notice that the select clause, we have ticker symbol, opening price, closing. The table is stock data, and we have a compound condition in the where clause. That means both conditions have to be true because it's an and. So the opening price has to be less than $120 and the closing price has to be greater than $120. So these stocks went up that day. Then we order first by open price, then we order by closing price, and they're both in ascending order. Let's do the question for query 7. List the ticker symbol, the high price, the low price for trades with a high above $250 or a low price below $50. Order the answers by high price and then by low. Let's walk through this one. We're looking at daily trading data for each stock. Each row in the table shows the high and low prices for a particular stock on a particular day. The question is, show me the days where a stock either had a really high peak, over $250, or dropped to a really low point, below $50. So we use an or condition because we're interested in either scenario. We're flagging outlier days where the stock was either way up or way down. Here is the query that answers the question. The from clause specifies the table, and since we are querying stock data including high and low prices, we must specify the stock data table. We are choosing three columns in our select clause: ticker symbol, ST_high, and ST_low. The where clause contains the condition of the price being over $250 or below $50. Then we add order by to keep the output tidy. We sort by ST_high first, then by ST_low in case there's a tie. This query helps us spot volatility, days where stocks moved outside the normal range, either up or down. Let's do the question for query 8. List all rows where any of the price fields equals 0. This means the open, high, low, or closing prices. Now, in real-world trading data, it's extremely rare for a stock's open, high, low, or close price to be exactly 0. That usually means something went wrong. Maybe the data wasn't recorded properly, or there was a system glitch. So the goal here is, show me any rows where the open, high, low, or close is 0. Here is the answer, and notice that once again in the from clause we specify stock data because that is the table where all of our data is. We choose select star because we want to return all the columns. We want to see everything about these rows, not just the prices. Maybe the date or the ticker symbol will help us diagnose the issue. We have to look at the open, high, low, or close being equal to 0, and notice that we connected them all with OR. When we execute the query, notice that no rows were returned, which means that we didn't have any data that was uncleansed. This is a classic data cleaning step. Before we analyze the numbers, we need to know if we can trust them. Let's do the question for query 9, which is remarkably similar to query 8. The question reads, list any rows in stock data that contain a null value. Here is the answer for query 9. This one's all about catching missing data, something that happens all the time in real-world data sets. We're working with stock data, and we want to find any rows where something important is missing, like the stock ticker, the trading date, or one of the price or volume fields. So the question we're asking is, show me any row where at least one column is null, meaning it was left blank or it was never recorded. In SQL, null does not mean zero. It means we don't know. The value is missing. We use isNull to test for that. And since any of these columns might be missing, we combine them using OR. In effect, we are saying, is the ticker symbol null? Is the trade date null? Is the open, high, low, or close price null? Is the volume null? We use select star to return the full row so we can see what else is going on. This is another data validation step. You'd usually want to fix or exclude these rows before doing analysis or building models. Here is the execution, and notice that no rows were returned, so we don't have any nulls in our data set. Let's read the question for query 10. List rows where the daily high is lower than the daily low, which would indicate a data error. Here is the answer to question 10. In query 10, we're checking for data errors in our stock data set. Specifically, we're looking for any rows where the reported daily high is actually lower than the daily low. That should never happen, so this query helps us catch mistakes, like typos or formatting issues. We simply use a where clause to filter rows where ST high is less than ST low. These are the kind of checks that help us clean the data before doing deeper analysis. Here is the question for query 11. List the ticker symbol, trade date, the opening price, and the closing price for all trading days in 2024, ordered chronologically within each ticker. Here is the answer to query 11. Query 11 asks us to return the opening and closing prices for all trades that happened in 2024. We're only interested in 4 columns: the ticker symbol, trade date, the open, and the closing price. The filter is straightforward. We use between 2024-01-01 and 2024-12-31 to keep just the 2024 dates. But here's the key detail. It asks for the results to be ordered chronologically within each ticker. That means we want to see each company's trades listed in date order. So we use order by ticker symbol, trade date. This groups the rows by ticker, and within each group sorts by date. Perfect for spotting trends over time or preparing data for a line chart. Here is the question for query 12. List the ticker symbol, industry, address, city, and zip code for companies whose industry description contains the word oil, ordered by industry and city. In query 12, we're searching for companies in the oil industry, but we don't need an exact match. We just want any industry description that mentions the word oil somewhere. And that's where the SQL keyword like comes into play. Like is used to find patterns in text. And the % symbol? Think of it as a wildcard. It means anything goes here. So this line, where industry like oil, means give me any companies whose industry field contains the word oil, no matter where it appears in the sentence. Could be crude oil extraction, oil and gas services, even bio oils. They'll all match. Then we order by industry and then city, which just means we're grouping similar industries together and alphabetizing the cities within each group, so the output is nice and tidy. We're selecting the ticker symbol, industry, address, city, and zip code. Great for building a mailing list or mapping out where oil companies are located. That's query 12, simple, powerful, and your first taste of pattern matching in SQL. Here is the question for query 13. List all distinct ticker symbols that contain the letter S. All right, query 13 is a quick one, but it introduces another helpful trick with SQL text filtering. We want to find all distinct ticker symbols that contain the letter S anywhere in the symbol. To do that, we use the like keyword again, just like in query 12. Here is the key line. That %S% means give me anything that has an S somewhere in the middle. The % before and after mean we don't care what comes before or after the S. And we're using select distinct to make sure we don't get duplicates. So if MSFT shows up 50 times in the table, it only shows up once in our result. This is a great query to practice string pattern searches and also to clean your data using distinct. Try changing it to a %A% or even S% to see how it behaves. The % wildcard gives you a ton of control. Here is the question for query 14. Show the average daily trading volume per ticker. Include only symbols whose average volume exceeds 15 million shares. In query 14, we're looking for the heavy hitters, stock ticker symbols that average more than 15 million shares traded per day. But to do that, we need to understand something new, and that is the group by. Normally, SQL gives us one result per row, but group by flips that. It says take all the rows with the same ticker symbol and treat them as a group. That way we can calculate statistics like averages for each group. In this case, we write select ticker symbol, AVG stands for average volume, and then we give it a nickname or an alias, and that's as average daily volume. From StockData, group by ticker symbol, having average volume greater than 15 million. Now here's something important. When you use group by, you can't use where to filter those averages. You have to use having. So this line, having average volume greater than 15 million, means only keep groups where the average volume is over 15 million. So we get a final list of tickers with serious trading volume. Perfect for narrowing down to the most actively traded stocks. This is one of your first aggregate queries, and it's a big step in using SQL to analyze trends, not just pull raw data. Here is the question for query 15. For each year, count the number of business days in the calendar table. In query 15, we're shifting focus to the calendar itself, not stock prices. The calendar table has one row for every single day on the calendar, and each day is labeled with a day type, either business, weekend, or holiday. What we want here is a count of all business days, the regular work days, for each year. So first, we filter the table with where day type equal business. That gets rid of weekends and holidays, leaving just work days. Next, we group those remaining rows by year using group by year number. This tells SQL, treat all the business days from the same year as one group. Then we count how many rows are in each group, meaning how many business days that year with count star as business days. Finally, we sort the results with order by year number. So the years appear in order from oldest to most recent. This is a great query when you're preparing time series analysis, like figuring out how many trading days are in a year, or aligning market data with real-world calendars. Execute the query, and you can see the final results of number of business days in every year for our calendar table. Notice that they all have between 258 to 261 business days in a year. Here is the question for query 16. Join StockData and CompanyInformation to list the company name, trade date, and closing price for all Apple trades in 2024. In Query 16, we're finally using one of the most powerful tools in SQL, the join. Why do we need a join? Our goal is simple. List Apple's closing stock prices in 2024 together with the company's full name and the trade date. But notice that the information lives in two separate tables. StockData has the open, high, low, and closing prices as well as the volume of shares traded. CompanyInformation has ticker symbol, company name, industry, and headquarters. If we just queried either table in isolation, we would be missing half of the story. Here in Figure 1, try to spot the common key. Ticker or ticker symbol is the common key. So SQL will line up rows where the stock data ticker symbol equals the company information ticker symbol. So what happens here? Every matching pair of rows is merged into a single, wider row that now carries price and company details. Here is the result of the join, which is a single table with the columns ticker symbol, company name, industry, trade date, and closing price. Now, each Apple trading day carries its full business context, exactly what analysts need when they track price movements against corporate events. Here is the answer for Query 16. We select company name, trade date, and closing price. And in the from clause, we do that join that we just talked about. We say from stock data as SD, join company information as CI on, left parenthesis, SD.TickerSymbol equals CI.TickerSymbol. Let's take a deeper dive into that from clause. From stock data as SD, SD is just a nickname for stock data. Join company information as CI, CI is just a nickname for the company information table. So what's with the nicknames? Nicknames or aliases save us from typing the full table name every time, like calling Alexander the Great just Alex. When do we use aliases? Only when column names might be ambiguous. Ticker symbol lives in both tables, so we preface it with SD or CI to keep SQL from saying, which one do you mean, buddy? Let's cover the where clause and the order by clause. We say where SD.TickerSymbol equals AAPL because AAPL is the ticker symbol on the stock exchange. We had to preface ticker symbol in this case with an alias. We could have done either SD or CI. We have to specify one of those or else it will give us an ambiguous column error. We also specify that the trade date has to be in the year 2024. In our case, we used a between clause, which includes the endpoints. Finally, we order by trade date so that our data comes out from oldest dates to newest dates. This query included several items, so make sure to go over it until you really understand it. Here's the question for Query 17. Find the highest closing price for each ticker symbol during 2025. Let's talk about the group by clause because that is the most important part of this query. Picture the daily closing prices tumbling out of the sky and landing in a bucket with the matching ticker on the label. The red bucket is AAPL or Apple, the blue bucket is MSFT or Microsoft, and the green bucket is GOOGL, which is Google. No card ever sneaks into the wrong bucket. Each stays loyal to its ticker. Now imagine a judge peeking into each bucket and grabbing the single tallest card, the best closing price that the ticker hit all year. Everything else stays behind. The arrow shows those champion cards marching onto a podium on the right. Each wears a shiny gold medal that says highest price of 2025. That's all the math behind the magic. Separate the data into buckets, pick the champion from each, then stack the champs in order. Easy on the eyes, and soon you'll see the query that makes it happen. All right, code time. Let's walk through this query line by line and see how it crowns one price champion per company. At the beginning, it is select ticker symbol, comma, max close as highest close 2025. The translation is give me each ticker symbol plus the single highest closing price it hit in 2025. We rename that column with an alias so the column has a title. The second line is from StockData. This is the table where every daily trade lives, our raw scoreboard. Where trade date between 25-01-01 and 25-12-31. We're telling SQL, ignore preseason and postseason. Only look at trading days in the 2025 calendar year. Group by ticker symbol. The magic phrase is one bucket per ticker. Now SQL slices the rows into separate piles. An Apple pile, a Microsoft pile, a Google pile, and so on. Order by highest close 2025 DESC. Finally, stack those winners from tallest to shortest so that the biggest price sits proudly at the top. Result, each company walks away holding its personal gold medal, its best closing price of 2025. Sorted so the show-offs are first. And that's the whole play. Once you understand the bucket, group by, and the trophy, max, combination, you can answer pretty much any best, worst, or average per group question in SQL. Here is the question for query 18. Identify down days where the close is less than the open and show the percent drop, ordered by the largest drop first. Not every trading day is sunshine and rainbows. Sometimes the stock opens high, closes lower, and leaves us with a sad red arrow. Let's hunt those days down and rank them by just how ugly the slide was. Here is the answer to the query, and there's a lot to cover here. But the first thing is really easy. We only want to include rows where the closing price is less than the open, which means that there's a drop. If there was an increase in price for the day, those rows are kicked out. You can tell that most of this query is really pretty straightforward, but this is the part that is probably going to cause you some heartburn. Let me help you with that. First, we take the open price minus the close, which is going to be a negative number. Then we divide it by the opening price, multiplying it by 100.0, and then we give it a name called percent drop. This may be your first time seeing an equation as one of the columns in the select clause. It's pretty common in SQL, and in this case, we end up getting a percentage drop, and we, in fact, named the alias percent drop. But let's talk about this 100.0. The 0.0 matters because in many SQL engines, if both numbers in a division are integers, SQL does integer division. It chops off anything after the decimal before multiplying. Goodbye precision. By writing 100.0, a decimal literal, we force SQL to treat the calculation as a floating point from the start. So 3 divided by 8 becomes 0.375. If it were integer division, it would be 0. Just for fun, let's illustrate that point. The first select is selecting 3 divided by 8 times 100. The second one is 3 divided by 8.0 times 100. When I click execute, you will notice that the first one here gives the value 0. The second one gives the value 37.5, meaning 37.5%. One of these was integer division, and one of these had an implied data type change. Finally, we look at the order by percent drop descending. Notice that we named the new column percent drop. So we order by that new column name descending, which means that we are going to see the largest drops first, followed by the smallest drop. Let's execute the query and then examine the results. Here are the results, and notice that we see a percent drop of over 66%, and then another one at 53%. So this is how you do a query with an equation in the select clause, and how we figure out something like which stock dropped the most as a percentage in a day. Here is the question for query 19. Return the 5 most traded days as measured by total market volume. In query 19, we ask a simple but revealing question. Which calendar days attracted the most trading activity across the entire market? Traders call these volume spikes, and they often coincide with earnings announcements, Fed surprises, or market-wide sell-offs. So our goal is to return just 5 rows. The 5 dates on which total share volume was busiest, so we can spotlight what was happening on those blockbuster days. Here's the query, and I want you to follow my line of thinking on how to solve it. The first thing we need to do is calculate a total volume of shares traded for every day, which means that all of the stocks that had a volume on a given day are added together. Total always means sum. Next, we need to group those rows together that share the same date. So we do group by trade date. Notice that we gave an alias to this new column and we called it total volume. We are going to use that in the order by clause. We are going to order by total volume descending so that we can see the largest volumes first, and then it will go to the smaller volumes. Finally, we list the top 5, which only shows the first 5 rows, which are the highest 5 because of the order by total volume descending. So that's query 19, and it really illustrates an important point that students often struggle with, and that is when to pair an aggregate plus a group by. Listen for an aggregate verb in the question, something like total, sum, average, largest, smallest, count, or number of. Then find the per what column. Clue words might be per, by, for each, or grouped by. For example, if we say, give me the average salary per department, we use the average aggregate and we group by department. Finally, we need to ask ourselves if we need to do a ranking. In our case, we wanted the largest 5. So we did an order by with a descending, and then we did a top 5. If we wanted to do the smallest 5, we would have just done order by and left off the descending, and then the smallest ones would have been at the top. Here is the question for query 20. List every company in the tech industry that does not have any trades recorded in 2025. Sometimes the most interesting data point isn't who traded, it's who didn't. Today's mission is to list every tech company that shows 0 recorded trade days in 2025. So let's think about that in plain English. First, we only care about tech firms, so we will have a where industry equals tech. Second, kick out any ticker that does appear in 2025 trades. This means that we will have a not in subquery. 3. That subquery should return every ticker that traded in 2025. So here's the answer to query number 20. Let's go through this piece by piece. First of all, we want to grab the ticker symbol and the company name, and those two exist in the company information table. Now the only industries that we want are tech, so we put that in the where clause. Now let's look at the inner query, the subquery, or this portion of the query. We are going to grab ticker symbols from the StockData table that had trades in the year 2025. This inner query then returns a list of ticker symbols that were traded in 2025. This inner query executes first and returns the list of ticker symbols to the outer query. Then the outer query says, give me all the ticker symbols and company names from company information, where industry equals tech, and ticker symbol is in the list that was provided by the subquery. Let's execute the query and notice that it returned 0 rows, which means all of the tech companies did have trades in 2025. But here's a bit of a secret. When a query is supposed to return 0 rows and it returns 0 rows, we have some level of comfort, but we can't be absolutely sure that it worked. So what we are going to do is insert a fake row and make sure that it is returned with this query, and then we can delete it when we're done. Then we have more confidence that our query worked. This code first deletes the temporary row if it already exists, then inserts a fresh one. Because the company I'm adding is in the tech sector and brand new to the table, it has no trading rows in StockData yet. After I run the insert, I switch back to my validation query and see exactly 1 row is returned. This confirms my query is working. I'm correctly pulling tech companies with no trades in 2025. As a note, you can manually insert a new row into the company information table. It is not required that you use the code that I did. After I finish this, I will just go delete this temporary company that proved my query was correct. Great work! We just walked through 20 essential SQL queries, previewing data, filtering, catching errors, joining tables, and even spotting down days in the market. If you can write these, you've got the core skills to explore, cleanse, and analyze stock data on your own. Keep practicing, experiment with new conditions, and you'll turn this foundation into real-world insights in no time. Thanks for watching and happy querying.